Hello everyone. I'm making this video because I'm getting some confusion, or I'm hearing about some confusion in terms of the difference between the different types of variables, and particularly between discrete and continuous variables. So I want to show you real quick what we talk about by discrete and continuous, and when you would choose each type. Here we have an example of 19 households and number of cars. Now this is something I would generally consider discrete data. Discrete data means that we can easily enough list every single possible value of the random variable x. So, in other words, we have a random variable and again the reason we call it a random variable is because you see in algebra, you solve an equation and x always has a fixed value. You just have to solve for it. What we're talking about here in statistics, and that's the big leap, is we're talking about random variables. A random variable more or less is the result of an experiment. Result of an experiment, or asking someone a question and getting some sort of data. So, in other words, if I roll a die, roll a six-sided die, I'm going to let capital X equal the number of dots that comes up, and it could be, again, 1, 2, 3, 4, 5, or 6. These are the possible outcomes. What the value of x isn't decided until the die is rolled, or in this case, until we've polled someone and asked them how many cars they have. But this is a discrete random variable because I can easily enough say, well, most households are going to have, I guess there's one household here that has 5 cars, but, when you're talking about a die, I can only roll 6 possible numbers. I can't roll an 8, I can't roll a 22, I can't roll a 2.5. There's fixed values, a very limited number of fixed values you can have. So, I guess, could people be really, really rich and have 15 cars? I guess. But I'm just going to assume it's a reasonably small number, and obviously a whole number as well. You can see when we make a histogram of this, which I have somewhere here. Oh, okay. There we go. So here's a histogram of that, and you see the rule of a histogram that the bars must touch, and we'll get into why that is in a moment. But again, you can see 0, 1, 2, 3, 4, 5, and the associated frequencies. So that's what a discrete random variable is. Now, a continuous random variable would be this. Let's say salary of employees at a company. Now I have, let's see, a fictitious company. I have, 16 employees here, and they range from $20,000 a year up to $200,000. Now, again, we're going to assume that these are integers, a whole number of values. We're going to assume that, we have all multiples of 10 here. Even with that restriction, that's a lot of possible values for salary. We have a range of $180,000, and even if we limit ourselves to multiples of 10, 180,000, that's still 18,000 possible values for x. That's a large number of values. So we're going to call this continuous because there's so many possible values that it's not feasible to list them all. And that is when we do a histogram. That's the wrong one. We do a histogram. Now you can see, well, we have to use classes. I can't just say, well, how many people make 20,000? How many people make 20,001 or 20,010? How many people make 80,000, 80,100, 80,200, 80,310? There's too many possibilities for me to give one tick mark to every possible salary value. So for convenience, well, a little more than convenience, we have to group these things. When we make it either histogram or frequency distribution, we have to group them, and that's what makes it continuous. So that's really the difference between discrete and continuous. Discrete, you can list every possible value. Continuous, it's either impossible to list every value, in that case for a real number. In this case, it is possible, but it's not something you're going to want to do. So you might then say, well, okay, if I make a histogram of this data, let me see, okay, 20,000, 21,500, or actually maybe a better way to put this might be, let's say I have continuous random variable. Where let's say I have a range. It's not behaving today. I have a range that goes from 0 up to 100, and I have 5 data points. Well, maybe 5. Okay, we'll see. I have 5 data points, and those 5 data points are 1, 3, 6, 9, and 96. Okay. So you may think, well, why can't we make this discrete data? I only have 5 data points, so I can have my x values over here. I can have my x values here, and my frequencies. Well, 1 is 1 time, 3 is 1, 6 is 1, 9 is 1, and 96 is 1. Why do I have to make this continuous data? There's only 5 data points. It's not the number of data points that counts. If I want to make this, if I were to make a discrete frequency distribution, I can't do this. I've got to do this. I have to actually list 1 or 0, 1, 2, 3, 4, 5, 6. I have to go list every possible value between 0 and 100. And I think, oh, okay. And this one will be 0, 0, 0, 0, 0. This is the proper way to do it. You cannot skip intervals. You cannot skip numbers. If this is my possible range of data, then a frequency distribution must list every possibility of x within that data range. Now, why is that? Because let's make from this data x and frequency. Let's go ahead and make a histogram from this. 1, 3, 6, 96, 9, and 96. And I make, let's say, histogram like this. Well, this is very misleading. This kind of assumes, you look at this graph and you kind of assume that it's a uniform, it looks like you have a uniform data set, which really isn't the case at all. Let's look at what it should what it should look like. Again, we're going to do this. Well, okay, obviously I can't list every possible value here. I'm just going to go eventually up to 96. So if I'm going to make a true discrete histogram, I'll make this 1. I've got to have 1 and 3 and 6 and so on. 96. Again, I have to account if there's a gap. If I don't have any numbers, and maybe I should erase this last part. If I don't have any numbers between 7 and 95, that has got to reflect. That's got to reflect in my histogram. This gives the very false impression there's a uniform data set. But if I have this long, again, I'm going to scrunch this up a little bit. Normally, this 96 is going to be way stretched off the screen. This gives me the impression that I have a uniform data set, when really this data set is very much right skewed, because you have one outlier, 96, that's all the way to the right. So I cannot just ignore 2, 4, 5, 7, 8, and so on. Can't do that. That's the other reason why bars have to touch, because there's a difference in having bars like this or in bars like this. This depicts a data set that's much more spread apart than this one is. So I have to keep the bars of equal width touching, and I can't skip any, because that gives a false picture of the shape of your data. So that's a difference between continuous data and discrete data. Discrete data we can list. Discrete data we can list every possibility, but with continuous data we can't. And if I were to just start skipping intervals, let's imagine this outlier and just kind of scrunch it all around here. Well, I can just, if I don't have to account for continuous data, I could just take this bar and scrunch it over against this histogram. But that makes a big difference. Is this bar, is this box over here, or is it out here? That makes a difference. When you're making a histogram, you have to be very precise with the width of your data, with where the gaps are, and with your intervals. Okay, so hopefully this clears up a little bit about discrete and continuous data. Any further questions on this, again, please feel free to ask. Okay.